Hello. Welcome, everyone. Thanks for coming. So this is an OpenXR tutorial, specifically doing rapid prototyping with OpenXR. So I'll talk about the low-level OpenXR experience outside of the game engine. So who am I? If you were here for the last one, this will be repeat, but my name is Alfredo Muñiz, and my day job is a CTO and co-founder of Exceed LLC. We develop full-body motion trackers, and I'm also the chairman for Khronos as a side thing. That is my email if you have any questions for after the talk. So first, I wanted to start with, and this is to make my presentation better. Why are you here? What are you building? Yeah, I want to hear from the crowd.
Training simulations for medical education.
A WebXR VR platform.
We're an XR training company in Sweden. So we're building training applications for customers in automotive and defense, maybe even medical in the future. We'll see.
Oh, very cool. Oh, the four of you.
Yep.
Oh, awesome. Yeah, that's really great. OpenXR has a lot of applications, and I'm very excited to hear them because, in the working group, the main focus from our developers is like gaming and, very much just trying to make it sellable to the mass market. So I'm happy to hear that there's more noble pursuits out there. So I'm going to cover what this talk is about and what it's not about. So if you take a look at this diagram, you have your game engines, you have WebXR. So these are all, in a way, they're libraries to access OpenXR. However, what we're going to talk about is the low-level approach. So this is where you can write code in, for example, Android Studio, and you can use it directly on an OpenXR compliant device. So I'll go through how to do this with the Quest 2 in this presentation. In terms of using it at a high level, using these game engines, there is a talk tomorrow in this room at 10:30 a.m. Unity will go over how to use OpenXR through their game engine, if you're interested in that. So let's move on. So I believe that the low level is underutilized, and it's really only used by game engines or software libraries. And usually they're only using it as like another abstraction layer on top of an abstraction layer. And sure, it makes it easy, but there's a couple drawbacks. Mainly when vendors release new features, it takes a while, on the order of a couple months or maybe even a year, for those features to become available in the game engine. Whereas if you use OpenXR directly, you can use those features, start experimenting with them, so that when they do become part of the game engine, you can put them in knowing that they'll work. So you can do quite a bit with OpenXR, such as isolating specific features. For example, if you just wanted to test hand tracking, you can do that in the low level pretty easily, and it'll compile super fast. Game engines, pretty bulky, take a while, and you have more control over the devices and the extensions and how they work. You can experiment, so you can add your own API layers. I talked about this in the previous talk, but API layers let you modify existing functionality. So if you wanted to do something different that's not being done, you'd be able to do that by accessing OpenXR directly. And you can even create your own extensions. You do not need to be part of the working group to do that. And it just, because of how much simpler it is, because it removes the abstractions, you'll actually see how the runtime works. You get to learn how OpenXR works, and you just know that way if you see any bugs when you do use the game engine, you can figure it out, you can report bugs, things like that. So, and not everything requires large libraries. Maybe you're making something very simple. That would be another use case for using OpenXR at a low level. So in terms of setting it up, it's actually pretty easy. If you started right now, brought out your laptop, you could probably follow along and build the tutorial, build the example. So I'm just going to go through the steps. So I have links there too, in case you want to look at the slides after and you want to go through the tutorial itself. So a lot of this follows the MetaQuest developer website. It is a little outdated, so some of the steps are unnecessary nowadays, but I'll cover those caveats in this presentation. So first, you'll need to set up the device. So for the Quest 2, you'll need to join an organization on Meta. Even if you're not part of an organization, you can be an individual with an organization. So that there's no issues there. You need to enable USB debugging. And this is so that when you connect the Quest 2 to your computer, it actually sends all the signals over. And one gotcha is that you have to do it in both the headset itself, but also the phone app. If you don't do it in the phone app, then it's not going to sync. And finally, you need to install the Android drivers. And this is just to be able to connect through Android's ADB interface. So that's all pretty quick. The next thing is you want to install Android Studio. It's about a 1 gigabyte software. So it takes a while to actually download. It took me about 30 minutes. So that's where the biggest chunk of time will be. And then that link describes the additional packages you need to install. Basically, the Quest 2 runs on a certain version of Android, and you just need to install that specific version. And then environment variables. So depending on what operating system you use, it can be easy or it can be a little more complicated. But if you're a programmer, you're probably familiar with how to do it. And then, of course, you need to your path variable add where your binaries are. When you connect to the Quest, you'll see this allow USB debugging. And there's a way to always trust the computer, which I recommend. Otherwise, it's going to do like 100 pop-ups when it's just sitting idle. All right, and I did this tutorial myself yesterday. So this is pretty fresh, and I know it works. All right, so OpenXR, we have in the repository one example that goes through what is OpenXR and how to run the simplest thing. So we call it Hello XR. And what you need to do is you need to download this OpenXR SDK source from GitHub. And then you'll open the project in Android Studio. You'll only need to do one modification, and that's to update the manifest to include this COM Oculus intent category VR. And that's it. So you no longer need to update the loader that it says on the other page, on Meta's page, which is pretty nice. So you'll compile it, and then you'll run it. And what it is you'll see this blue square that always follows you. And then if you pick up your controllers, those will be tracked. So you're able to see them in 3D, and they show up as cubes. And if you pull the trigger, that cube will get smaller. And if you pull it, I think it's like 90%, it'll start to vibrate. So it also shows off the haptics. So that's pretty cool. And it is one of the basic examples. So I recommend if you're new to OpenXR that you do this first, because it'll really give you a good idea of how it works. So right now I'm going to actually go through the example itself. First, by giving an overview of a typical OpenXR app. So first, you need to create an instance. And the instance basically says, this is a headset, this is what it does, this is what it supports, that sort of thing, and this is the graphics API that it uses. You'll need to, so the device will tell you what it supports. So it'll tell you, is this one screen? Is it two screens? Is it for your head? Is it just like a standalone thing? And then you'll need to set up the bindings. So these are the actual actions. And I'll talk more about these later because the action system is a bit complicated. And then you'll create your session, a swap chain, swap out the buffers for the two displays. And then the loop, the grand loop, it just updates everything. So all the poses, the inputs, the haptics, and the displays. So it's at a high level, very simple. If you open up the code, it's very long and it may be a little daunting. So I'm going to try to break it down in a way that's not as scary. So first, you'll see initializations. So this is specifically in main, so main.cpp, or I think in there it's helloxr.cpp. But it starts off with these kind of class initializations. So you'll have three: the platform plugin, the graphics plugin, and then the OpenXR program itself. So the platform plugin, that is to abstract away the actual platform. So whether it's a head-mounted display or a handheld display, such as a AR phone, it doesn't matter to OpenXR, but OpenXR needs to know to be able to abstract that away. Same as whether it's a single display or a dual display. And then the blend mode, which Danny will talk more about in his presentation. And then we also want to abstract away the graphics API. So whether you're using D3D12, Vulkan, or OpenGL, your application doesn't need to know about that, but it does need to be specified by the device itself, which one it's using, so that it can load the proper API. So, and then program is where you actually write your code. So, you'll see here more code snippets. So the program class has a create instance, which establishes the connection to the runtime. We call it runtime. You can think of it as headset, because that's what it is with a few exceptions. But it's better to just think about it as a headset. And then this will let you sort of print the properties of that specific headset. So if you just have a Quest, you're able to see what it supports, and then all the different properties that it has, which is very nice because otherwise you wouldn't know. So that's the way for it to tell you what it can and cannot do. You'll then initialize the system. Let's see, and then you'll want to initialize the device. So the graphics API needs the system ID and the instance handle from initialize the system to be able to do the graphics API. So these are details that they're kind of just, what do you call it? They're kind of just automatic. You just put it in the app. You don't really need to know how it works. But the example itself, it does have comments, so you can at least understand or read the comment of what it does. So from there, you can initialize session, which connects it to the graphics API. And then you'll set the reference space, the view, local, or stage. And these are all specified in the OpenXR specification. So they describe different ways that the view will be seen. And then the action set, which will be described in detail on the next page. And then the swap chain. So the swap chain is just where you're able to render the consecutive views without having like screen tearing. So they just go back to back, so it looks like a smooth picture. So here's an overview of the action system. We decided, well, the people before me decided to make it human-centric and not computer-centric. So if you think of a standard such as HID, for example, the human interface device with the USB, you're able to manipulate buttons directly. OpenXR decided, let's abstract away the hardware. Let's make it such that the developer doesn't need to care about the hardware. They only need to care about what it's doing. So this is where this action system came to be, where, for example, if you want something to be a grab action, different vendors will implement that differently, but they would bind to their own hardware-specific platform. So that's the general idea, and we're trying to expand it to make it more compatible with game engines, because game engines do a lot more, and we're trying to meet them where they are. So it'll go through a little revamping, but it's for the better. Still keeping the same logic of abstracting away the hardware, focusing on what is the user doing. And then, so this is done by what we call bindings and interaction profiles. So if you develop, for example, on the MetaQuest, Oculus Quest 2, then you would be using their interaction profile. You can suggest that to the app, and then the runtime will read that, and they'll be like, oh, this application was developed with this controller in mind. The runtime, the headset, will then say, oh, okay, that's not my controller, but I can map that to my own controller. So that's the idea behind that. And lastly, there's the while loop that I mentioned. So this will just pull actions and render until you tell it to stop. Not much more there. So those are pretty much the basics. There is a lot more to low-level OpenXR development, such as adding in extensions and API layers. These are completely optional, but they are pretty powerful, and they add additional functionality. With the OpenXR, with HelloXR, it is a nice exercise to add in extensions or API layers as like a practice. And then there's action system multiplexing. So if you read the specification, the action system is, again, this complicated, garbled mess that works good in simple cases, but when you start complicating it and having multiple bindings to the same action, it gets very confusing very quickly. So it's worth reading up on that. And then the OpenXR loader is not touched on at all in this presentation. And there's a lot of little details like that. And It's beyond the scope of this presentation because a lot of it is you kind of have to learn as you go. And unfortunately, that's the reality of a lot of software development. And OpenXR is no exception. So if you want to, once you build Hello XR, I recommend getting the Oculus Mobile SDK and running their examples. So they have a couple of like eye tracking, hand tracking, and they're pretty complete. So you're able to see on a low level how those things work, how to add extensions, that sort of thing. And if things are unclear, the answer is most likely in the specification itself. Again, this big document that may slow down your computer. And it covers a lot of things such as initialization, instances, the input and haptics, and even the extensions and API layers. So it's pretty thorough. If there's something we missed or something that's unclear, that is something we would like to hear from the community so that we can fix it and make it more direct. So you can do that by leaving an issue on our public GitHub, specifically OpenXR docs or OpenXR SDK source, where you downloaded the example. We can also be reached at the Discord channel, which is linked here. Some members are pretty active on there, and they will respond like within a few hours. So we're a pretty good community. We're about 50 developers or so from, Meta, Microsoft, and a lot of big and small companies. And I think we're all pretty passionate trying to move this forward and just trying to make XR a better, easier place for developers to make applications. So that's it for my portion of the presentation. Denny will come up here and give his portion, and then we can take questions.
Hello, everybody. So now we're gonna change focus a little bit and look at how to enable video pass-through. So in 10 minutes, you're going to learn how to do this. It's actually super easy once you know how to code for OpenXR. Essentially, there are two takeaways here. So first, if you're an application developer or a game engine developer, the takeaway is that OpenXR is here today to support this use case. Secondly, if you're a device manufacturer, then the takeaway is that you can bring your device to OpenXR and then enable this functionality with the core OpenXR that we have today. So I'm Denner Rönngrön. I joined the OpenXR working group in 2018 when I was working for Tobii. And then I was working mainly with eye tracking. Recently, I joined Varjo, and like now I work as a developer and as a PM actually to support our headset and try to drive the standardization forward. And it's actually quite nice to be both developer and PM, actually. So let's get started. Here we have, like the spectrum of devices, and on, let's see, the left-hand side we have a VR device, and a VR device replaces all of your real world with rendered content. Then the two devices on the right are mixed reality devices. So like we have the Magic Leap 2 and then we have Varjo XR3. They are using different technologies in order to do this. So the Magic Leap uses something that's called optical see-through. And then they add, like pixels on top of the real world because you essentially wear it like a pair of glasses. But the video pass-through is different because then you have low latency RGB cameras that are pointing outwards, and it's very important is low latency. And here we have the opportunity to completely replace the real world or to mix them together. And it's actually quite easy to make them blend together because both of them are rendered